deviation, or SD, is, is sort of like the average, deviation. But we do a little bit more that we're going to do time and again in statistics so that the formula isn't quite as easy as we want it to be. If it was the average deviation, it would look like this. Equals, we know what an average is. We would take the sum of all the deviations. Don't write this down because this isn't going to be right. And we divide by n. And that would give us an average deviation. But we're going to make it a little more complicated than that because we're going to add 2 steps to it. The first thing we're going to do is, instead of taking the sum of all the deviations and leaving it there, we're going to take the sum of all the deviations squared. So we're going to take all those deviations and we're going to square each one of them. And then we're going to divide by n. And then for our last step, because we squared all those things, we have to take the square root of that figure that we get. So this is the formula for standard deviation that we'll be using at this time. So to go over that again, the steps we're going to follow are these. First, we're going to calculate the deviation for each score. How far is each score from the mean? We've just done this. Next, we're going to square each deviation. Then we're going to sum up these deviations to get what we call the sum of squares. So the sum of squares we're going to work with a lot. It's the sum of all those deviations squared, each deviation squared, and that's called the sum of squares. Then we're going to divide by n, this step we looked at here. And we're going to get something we call the variance. And the variance is just sum of squares divided by n. That's our variance. And then we take the square root of that. For our standard deviation equals the square root of the variance. Those are the steps we're going to follow. And this is the formula in its complete form. But we're going to be using these steps, and so let's do an example now. So guided practice, this is just what we're going to do in class here. So we can see our scores, and I'm going to make this really small. This is an example of what a problem might be. We're actually going to skip a little piece of this here. All we're going to do is find the mean and standard deviation, and then we're going to explain it. Okay, if we can. We're going to find the mean and standard deviation. There we go. So let's go ahead and lay out these scores. Let's organize our data in a nice readable raw form. If you have had math classes in the past, they might organize a problem like this a little differently. I'm going to encourage you to use this table form to organize your data, because this is how we're going to be doing it in Excel, so this will help you. So what I want to do is first write down the scores. And so if I looked at the data, what we would actually have here, I'm going to take this heading off here and move this problem up so that I can, so that I have a little more room to write. So here we go. So we have, for the raw data, we would have, first of all, we would have game 1. I'm going to put G1, G2, G3, G4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to game 10. And then if we organize the scores, we're going to have, I'll put a heading here that says X, and we'll have 0, 3, 6, 8, 2, 9, 7, 6, 4, and 5. And next we have to calculate our deviations. So our deviations, remember, is x minus m. And so in order to calculate x minus m, we have to calculate m. Remember what m is. M is the sum of all the scores divided by n. And so m equals the sum of all of these values. So I'm going to add them up. 5 and 4 is 9, and 6 is 15, and 7 is 22, and 9 is 31, 33, 41, 47, 50. Divided by 10 equals 5. So in this case, the mean of this distribution is 5. So let's figure out each deviation. The first score is 0, x minus m, 0 minus 5 equals negative 5. 3 minus 5 equals negative 2. 6 minus 5 equals 1. 8 minus 5 equals 3. 2 minus 5 equals negative 3. 9 minus 5 equals 4. 7 minus 5 equals 2. 6 minus 5 equals 1. 4 minus 5 equals negative 1. And 5 minus 5 equals 0. So now we have the deviations. Next, we need to figure out for each score the deviation squared. Deviation squared, or x minus m squared. We've already figured out x minus m, so all we have to do is square it. So negative 5 times negative 5 equals 25. Negative 2, I'll just put this dot, times negative 2 equals 4. 1 times 1 equals 1. 3 times 3 equals 9. Negative 3 times negative 3 equals 9. 4 times 4 equals 16. 2 times 2 equals 4. 1 times 1 equals 1. Negative 1 times negative 1 equals 1. 0 times 0 equals 0. And so these are our deviations squared. Our next step is to sum all those squared deviations up. So we're going to put SS, which means sum of squares, and down here, I'm going to write SS equals sum of squared deviations, or we usually just say the sum of squares. So that just means the sum of deviations squared, or the sum of x minus m squared. Notice that x minus m and deviation are the same. So we sum our squared deviations. We have to just add all these up. So I'm going to start with 16 and 4 is 20, 21, 22, 31, 40, 41, 45 plus 25. 45 plus 25 is 70. So our sum of squares is 70. Next, I think I'm going to get a different pen so this isn't so filled up with red. Next, we calculate what we call our variance. Sorry, I didn't get my pen I was going for. Our variance is just sum of squares divided by n equals 70 divided by 10 equals 7. VAR equals variance. And the variance is a strange number that doesn't make a lot of intuitive sense, but we use it all the time when we're calculating. So it's important to understand the idea of variance. And lastly, we're almost done. We simply have to get our standard deviation. Our standard deviation equals the square root of the variance, equals the square root of 7. And for that, we need to use a calculator. So here is my calculator. Sorry if that screen got lost a moment. I think you still see it now. And so the square root, we're just going to write, I believe this way. I don't use my calculator much. So I'm going to hit 7 and put the square root sign, I think. And I get 2.6457513, et cetera, et cetera. We don't need to write all of this down. We can just, usually 4 digits is the standard. If you're in the middle of a formula, and then if you're presenting your results, you usually stick with 2 digits. Since we're doing the math, we'll err on the side of caution and use all 4. So I'm going to take the 7 at the end. It's followed by a 5, so I round up. So I'm going to round it to an 8 and write standard deviation equals 2.54. Let me see, what was that last number again? 6458. 6458. And so now we finish this problem. The answer to this problem would be M equals 5, standard deviation equals 2.6458. And that means, if you were going to explain it, that on average, this basketball player scored varied from the mean, the number of points scored by this basketball player varied from the mean by a little over 2.5 points. So if I was going to write an answer that involved writing the answer and explaining it, my answer might look something like this. M equals 5. Standard deviation equals 2.6458. And then I would write, explaining this to a 6th grader. What that means is you're explaining it in words that would be easy to understand by anyone. So I would say, on average, this player scored 5 points per game, but the points he scored in any individual game differed from the mean by approximately 2. I'm going to write and a half just to keep using words, approximately 2.5 points. And I think that would be good. I think that would be acceptable. Questions about what we've done with standard deviation. And remember, any questions you have are good ones. So I'd love to have some questions right now before we do another example and begin to start our application problems. Virgie, hi. I am there in person next week. I hope you'll come back. Please come back. Stephanie said she's coming back. Sherilyn's coming. I hope Colin's coming. What questions do we have? Stephanie, how is this seeming to you? Does this make sense to you? This is time consuming. That's why we're going to do this next problem.
Yeah, it makes sense because it kind of goes along with the first assignment that we did with explaining the normal distribution and the kurtosis, just the shape of the distribution. And then how at the bottom you had us explain what we were